Under a vast, indifferent sky, the countdown had already begun. November 8th wasn't just a date on a calendar anymore. It was a threshold, a point in history when humanity would raise its eyes and for a moment face something born beneath another sun. Across control rooms, observatories, and quiet homes where small telescopes waited beside coffee cups, people felt the same pulse of anticipation. Something was coming, something real, not a movie, not a theory, a messenger from beyond. The name was simple enough, 3I/Atlas. But simplicity was an illusion. For almost a year, this faint traveler had rewritten every rule astronomers thought they understood. It didn't act like a comet. It didn't fade or flare when models said it should. It shimmered in defiance of prediction, whispering in wavelengths the equations couldn't explain. The data didn't make sense. The chemistry didn't fit. The patterns mocked probability. And yet, its motion, its perfect silent glide through space, was carved in the cold mathematics of celestial mechanics. No chaos, only an unfamiliar order. When the Atlas survey first spotted it in December 2024, it was just a dim point sliding through the constellation Ursa Major, unremarkable except for one number, the eccentricity of its orbit, greater than 1, the telltale signature of something unbound by the sun. Every world in the solar system, every rock and ice and dust grain, moves in an ellipse, but not this. This one was hyperbolic, a visitor passing through only once before vanishing back into the interstellar dark. That single number whispered the truth. 3I Atlas didn't belong here. Within days, telescopes across the planet swiveled toward it. From the European Southern Observatory's domes in Chile, to the Subaru telescope in Hawaii, to the orbiting eyes of Hubble and James Webb, the world's instruments synchronized like a symphony tuning for its first note. Scientists spoke in the language of precision, exposure times, spectroscopic gains, photon counts, yet behind every technical phrase pulsed a simple, childlike wonder, a traveler from another star, a chance to see something older than our own sun. The first spectra came back, and expectations shattered. Most comets, even those born in the cold reaches of our solar system, are built on familiar chemistry: water ice, carbon dioxide, organic dust. But Atlas was different, an inverted world. 8 parts carbon dioxide to 1 part water. Its molecular fingerprint told of a birthplace far colder, far darker than anything near our star. Somewhere out there, in a stellar nursery rich in carbon and shadow, molecules had frozen before they could blend, sealing alien chemistry inside crystal cages. And now, after perhaps 1,000,000 years drifting between suns, sunlight was waking it, coaxing it to speak in plumes of carbonic vapor. But even those plumes disobeyed physics. Atlas flared before solar heat could reach it. It glowed while still beyond Mars, where water should have remained locked solid. Swift Observatory detected hydroxyl emissions, water vapor signatures, at temperatures that made such release impossible. The brightness didn't vary with distance from the sun. It pulsed irregularly, as if responding to invisible tides. Some theorized magnetic fields. Others spoke of trapped supervolatiles or electrostatic charge building deep within. No one could agree. The equations bent under the weight of the unknown. By early summer, the name 3I/Atlas had spread beyond scientific circles. News anchors stumbled over the numbers, documentaries whispered of the messenger comet, and social media thrummed with hashtags, #AtlasWatch, #BeyondMars. Yet amid the noise in observatories, both grand and humble, the sense of awe remained sacred. This wasn't danger, it was discovery. No apocalypse, no omen, only possibility. NASA's Jet Propulsion Laboratory became the quiet heart of the operation. Teams calibrated instruments to atomic precision. Servers hummed with simulations predicting November's encounter. The James Webb Space Telescope reserved infrared time to trace carbon compounds. Hubble prepared for optical imaging at maximum gain. The Very Large Telescope in Chile would measure light polarization. searching for secrets hidden in the dust's reflection. Every second of data mattered. Every photon was a clue. And yet, amid all the engineering and mathematics, a deeper truth stirred. The excitement wasn't just about numbers, it was about meaning. Each scientist, from the interns checking calibration logs to the directors signing off observation schedules, felt it. The hum of wonder, the old question echoing in modern language. What if the building blocks of life weren't ours alone? What if this visitor carried echoes of chemistry that once danced beneath a different sun? In a quiet corner of JPL, Dr. Elena Cortez adjusted her headset, eyes fixed on a real-time simulation. If it's reacting this early, she murmured, something else is driving it. Her colleague leaned closer. Internal heat source? She shook her head. Not heat. Something deeper, maybe magnetic coupling, maybe quantum frost reaction. I don't know yet. That sentence, I don't know yet, was the most honest phrase in science. It was the heartbeat beneath every discovery. Outside the lab, the world waited, the countdown ticked. November 8th approached. In schools, teachers projected orbital maps onto classroom walls, tracing Atlas's hyperbolic path with fingertips. In backyards, amateur astronomers polished mirrors, hoping to glimpse a faint blue shimmer through the dark. The story had transcended academia. It had become collective, a shared breath held between curiosity and awe. But fate, or perhaps physics, wasn't finished weaving its coincidence. Somewhere between Mars and Jupiter, another mission drifted silently. NASA's Europa Clipper, en route to study the hidden ocean beneath Jupiter's frozen moon. By pure celestial geometry, its path would intersect the outer dust trail of 3I/Atlas, a cosmic accident, a crossing of purpose and chance. If calculations held, the spacecraft's dust analyzer, built to study ice particles from Europa's plumes, might record micro-impacts from interstellar grains. Material that formed around another star could touch human machinery for the first time. Inside mission control, engineers recalculated trajectories. "What are the odds?" someone whispered. "Millions to one," came the reply. But they just got real. The possibility electrified the air. If even a single particle struck the analyzer, it could carry the fingerprint of alien formation, ratios of carbon to oxygen, isotopes of nitrogen unknown in our system, maybe fragments of molecules that once floated in the newborn atmosphere of a distant sun. For centuries, humanity had stared at the night sky and wondered. Now, for the first time, the universe might reach back, not with a message in light, but with a speck of dust. In those final weeks before the crossing, science met poetry in perfect balance. NASA's official updates read like lines of scripture for the curious. Europa Clipper's dust analyzer in passive readiness. James Webb preparing infrared lock on target coordinates. Global observation network synchronized to plus or minus 2 milliseconds. Each line dry, technical, and yet beneath it, something alive stirred. In interviews, Dr. Michio Kaku's voice carried the weight of both physics and philosophy. 3I/Atlas is not just a comet, he said. It's a time capsule from another star system, a message in molecular form. When we observe it, we're not just studying ice and dust. We're reading the chemistry of creation itself. The word spread like fire through social feeds and newsrooms. People who had never cared for orbital eccentricity or isotopic ratios found themselves entranced by the poetry of science. Because in the end, this wasn't about equations, it was about belonging. If molecules could travel from one star to another, then maybe the universe wasn't a void at all. Maybe it was a bridge. As the last days before November approached, an almost spiritual stillness settled over the global astronomy community. Observatory domes stood ready across continents. Servers waited, humming softly like instruments before a symphony. Telescopes, both ancient and modern, aligned toward a single patch of darkness beyond Mars. Humanity had built an orchestra of glass and metal to listen to the silence of space. The narrator's voice, steady, calm, filled with reverence, carried through the control rooms. Every second of light we capture tonight will travel millions of years to reach us. Every photon is a memory from another sun, and somewhere out there, 3I/Atlas kept moving, indifferent to the anticipation it had inspired. It glided through the black, tail faintly shimmering, carrying the chemistry of its home star like a secret sealed in ice. It didn't know it was being watched. It didn't care. But its presence, quiet, precise, and impossible, had already begun to change us. The night before November 8th, the world stood on the edge of revelation. The equations were ready. The instruments were armed. Humanity waited for the universe to speak. The night descended over the deserts of Chile, the mountains of Hawaii, and the silent vacuum of orbit. Observatory domes unfolded like petals of metal under the stars, their glass eyes tilting in unison toward a single destination. The countdown was over. November 8th had arrived. Somewhere beyond Mars, 3I/Atlas drifted through the void, an ancient traveler crossing an invisible frontier of solar wind and magnetic turbulence. Humanity watched, waiting for the first whisper of data to return. Inside NASA's Jet Propulsion Laboratory, screens glowed in the dim light of the control room. Streams of numbers flowed across monitors, spectral graphs, emission lines, photon counts. Engineers leaned forward, breaths held, the air humming with quiet electricity. Then a voice broke the silence. "Webb has signal." Heads turned toward the main display. A faint spike appeared in the infrared spectrum, carbon dioxide flux increasing, then stabilizing. Another voice followed. "Hubble confirming visual gain, object brightening." A murmur rippled through the room. It had begun. At first, the data seemed ordinary, predictable fluctuations as sunlight struck frozen carbon, but within minutes the reading shifted. The brightness didn't rise smoothly, it pulsed, irregular, rhythmic, like the flicker of a heartbeat. Once every 43 minutes, a surge. Emission peaks spiked and fell in perfect cadence, repeated again and again. No comet had ever done this. The numbers whispered something alive within the mechanics. At the Very Large Telescope in Chile, polarization data came through next. "Negative reversal detected," one scientist said, voice trembling. The dust around 3I/Atlas was scattering light backward, defying every known behavior of particulate reflection. On screen, the comet's halo shimmered like a living pulse of blue and white, its tail twisting into a double helix pattern that spiraled across space. The control room fell silent. Words failed. For a moment, all that existed was wonder. Across the world, the images began to spread. From the European Space Agency to amateur astronomers in suburban backyards, telescopes everywhere captured the same pattern, the heartbeat of light, pulsing from a traveler between stars. On social networks, hashtags erupted. Hashtag Atlas Pulse, hashtag Heartbeat from Beyond. Commentators tried to explain, but none of them could. The comet seemed to breathe. The sky itself felt sentient. At JPL, Dr. Elena Cortez stood before the data wall, eyes fixed on the rhythm scrolling upward. "If it's periodic," she whispered, "it's not random outgassing. It's triggered, something internal, magnetic resonance, rotational coupling." Her colleague turned, skeptical. "You're saying it's reacting to the solar wind?" She nodded. "Or something deeper. Maybe the same way auroras react to Earth's magnetosphere, but amplified 1,000-fold. Silence followed, heavy with possibility. The line between science and mystery blurred. Hours later, as 3I/Atlas crossed the densest region of solar wind, the emissions flared violently. Brightness surged tenfold, painting a spectral signature of compounds no one had predicted. Methanol, formaldehyde, even traces of glycine precursors, the first molecular whispers of life's foundation. The readings were clear. This was chemistry forged under another sun. Every molecule told a story from a world humanity had never seen. On live broadcasts, Michio Kaku's voice narrated softly over real-time footage. "We are witnessing alien chemistry at work. Matter shaped in the cradle of another star, reacting to our sun's invisible breath. This is no longer theory. This is the universe speaking." People across continents fell silent before their screens. Children watched the glowing spiral tail on classroom projectors. Couples stood outside with binoculars, tracing faint lines of light. Pilots at cruising altitude dimmed their cockpit lights just to glimpse it. For the first time in years, the world looked up together, not in fear, but in awe. Then, somewhere far beyond, another story began to unfold. The Europa Clipper, gliding through its trajectory toward Jupiter, entered the coordinates where models predicted the faint edge of 3I/Atlas's debris field. The spacecraft's instruments, built for the frozen plumes of Europa, switched to passive monitoring. At first silence, then the faintest tremor, a micro-impact, another, then another. A dozen tiny collisions registered in under a second, each grain smaller than a sand particle, traveling tens of kilometers per second. The detectors captured everything: mass, velocity, composition. The signal was faint, but the data undeniable. The onboard analyzer transmitted the first results back to Earth: carbon, oxygen, hydrogen, familiar fingerprints, but layered beneath them, peaks of complex carbon chains, organic molecules larger than anything previously detected in interstellar material: methanol, formaldehyde, fragments of amino acid precursors. It was a message written in atoms. When the data reached JPL, the control room erupted into motion. Analysts confirmed the isotopic ratios: carbon-13 levels, oxygen 18 variances, all markers of chemistry forged in a colder, older system. Elena stared at the screen, tears welling in her eyes. "It's real," she said softly. "It's all real." Across the world, as dawn broke over continents, the news spread faster than light. Humanity has touched another star. Headlines flashed across every major network. Scientists struggled to contain emotion during press briefings. "We've recorded direct contact with material formed beyond our solar system," one announced, voice trembling. "And within it, the building blocks of life." In Tokyo, children pointed at the morning sky. In Paris, cafes buzzed with disbelief and wonder. In small towns and megacities alike, strangers gathered to talk not about politics or war, but about dust, microscopic grains that had traveled light years to meet us. The human race, so used to division, paused as if sharing the same heartbeat as the comet itself. Back in Pasadena, Michio Kaku addressed the press from the JPL auditorium. "For centuries," he began, "we have looked at the night sky and asked, are we alone? Tonight, the universe gave us its first whisper of an answer. Life may not be unique to Earth. It may be the melody written into the very fabric of matter, the seeds of existence drifting between stars, waiting for warmth and time." The applause that followed wasn't loud, it was reverent, like the sound of breath released after a miracle. Outside, the sky remained indifferent, but in the hearts of those who watched, something shifted. The cosmos didn't seem distant anymore. It felt close, intimate, alive. As hours passed, the comet began to change again. The violent pulses softened. The brightness dimmed to a steady glow. Some scientists called it exhaustion, others equilibrium, but to those watching, it felt like something else, a farewell. The heartbeat faded, but its echo lingered, rippling through humanity's imagination. Dr. Cortez leaned over her console one last time that night. On her screen, a faint graph traced the final emission decline of 3I/Atlas. She smiled through exhaustion. "It came to show us who we are," she whispered. And maybe that was true. In the fading light of a comet from another world, humanity saw a reflection of its own longing to understand, to reach, to belong. Above the world, beyond Mars, the traveler kept moving, shrinking into the darkness, its luminous breath trailing behind like a thread of memory. The instruments continued recording. The data kept flowing, but the meaning had already transcended the numbers. Something ancient had spoken, and for the first time in human history, we had listened. The light was fading. By the time Earth turned through another sunrise, 3I/Atlas had begun to drift beyond the reach of most ground telescopes. Its glow softened into a thin spectral haze, a whisper more than a presence. But inside the data stream, still humming across NASA's servers, the story was far from over. Every byte of information, every molecular trace from Europa Clipper's sensors, carried secrets of another world. Humanity had gathered a message, written not in words but in chemistry, and now it was time to read it. At the Jet Propulsion Laboratory, scientists worked through endless hours, eyes bloodshot, hands steady. Spectral graphs overlapped like the lines of an alien language. Ratios of carbon to oxygen told of a birthplace far from the warmth of any familiar star, a red dwarf system, ancient and dim, where light came in long, cold pulses. Metallic traces hinted at dust forged in an environment richer in nickel than iron, something no comet from our solar system had ever shown. Every molecule seemed to hum with memory. It's not just foreign, Dr. Elena Cortez said quietly during a late-night debrief. It's ancestral. This thing remembers where it came from. In conference rooms around the world, the analysis unfolded like a revelation. Methanol, formaldehyde, carbon dioxide, and traces of glycine precursors, each compound an ingredient for life. Nothing living, but everything essential. Together, they painted a portrait of universality, a chemistry that didn't belong to one world, but to all worlds. For centuries, the idea of panspermia, the notion that the seeds of life could travel between stars, had been dismissed as poetic speculation. But now the data was irrefutable. Those seeds were real. They had survived the void. On global broadcasts, the news anchors spoke in tones of reverence. For once, headlines weren't about conflict or fear. They spoke of discovery, of unity, of the astonishing fact that life's raw ingredients drifted freely through the galaxy. Humanity has touched another star, one headline read, and no one disputed it. Across social media, the hashtag #OneCosmos trended for days. Artists painted visions of interstellar seeds. Musicians composed symphonies named Atlas. Teachers wrote the date on classroom whiteboards and circled it, November 8th, the day the universe answered softly. In Geneva, at the International Science Forum, Michio Kaku stood before a sea of cameras. His voice carried the same calm wonder that had guided millions through the event. "We witnessed a messenger from another sun," he said. "It didn't come to threaten us or test us. It came to remind us that the universe is alive with possibility. The chemistry of creation doesn't belong to Earth. It belongs to everything." The hall was silent except for the sound of typing, reporters capturing words that already felt like history. Back at JPL, the Europa Clipper team continued their review. One final transmission from the spacecraft confirmed it had crossed safely through the debris field. Dozens of micro-impacts analyzed, cataloged, preserved. A few fragments showed polymerized carbon chains longer than any expected formation under natural radiation. It was as though time itself had sculpted complexity into the dust. Elena stared at the last data feed, a faint line of peaks and valleys across the screen. "It's not just data," she whispered, "it's inheritance." Outside, the sky was clear over California. Some of the same scientists who had monitored Atlas during its peak gathered on the building's roof, coffee cups in hand, gazing upward. The comet was gone from naked sight, but they looked anyway. There was comfort in knowing that somewhere out there, the traveler continued, fading into the same darkness it came from, carrying humanity's questions with it. "We only saw its light for a moment," one engineer said, "but maybe that's all the universe ever gives us, moments." By mid-December, 3 I/Atlas had dimmed beyond detection even for the largest telescopes. Yet in that vanishing, it left a legacy brighter than its tail. Research papers began to emerge. Polarization anomalies in interstellar objects, volatile ratios of 3 I/Atlas, evidence for carbon-dominant ices, direct sampling of extrastellar organics by Europa Clipper. Each title marked a step forward, a bridge across the unknown. Humanity had glimpsed how matter could remember its birthplace, how molecules could carry history across light years, how the same ingredients that shaped us might shimmer in the dust between stars. On December 21st, the final broadcast of the project aired. The screen faded from static to a deep black void sprinkled with starlight. Then Michio Kaku's voice returned, soft, reflective. We have watched a messenger from another star pass through our home. It brought no fear, only understanding. It reminded us that the universe is not silent. It speaks through chemistry, through light, through time. We are made of the same story it carries. Every atom within us was once part of a star. Tonight, as 3I/Atlas drifts beyond our reach, it takes with it our curiosity, our courage, and our promise to keep searching. The footage transitioned to images of telescopes shutting down one by one, the domes of Chile closing, the mirrors of Webb rotating back toward calibration, the last flicker of Atlas's recorded tail disappearing into data archives. Over the montage, a single line of text appeared. November 8th, the day we reached across the stars. Then silence. Not the silence of emptiness, but of completion. Somewhere, a child watched the replay and whispered the comet's name under their breath. Somewhere else, an old astronomer smiled, knowing they had lived long enough to see the universe write a new chapter. Above it all, beyond the reach of instruments, 3I/Atlas continued its endless drift, no longer a mystery but a bridge. It would travel on for eons, through radiation storms and cold interstellar tides, carrying the dust of its home and the fingerprints of ours. And long after it vanished into the void, the knowledge it left behind would remain, a reminder that the cosmos is not a void but a garden, scattering its seeds in every direction. In that knowledge, humanity found something deeper than discovery. It found connection, the awareness that we were never alone, that every spark of matter shares a common origin. And as the broadcast faded to black, one final voice echoed softly, a closing thought carried like a prayer. The universe spoke. We listened. And in listening, we remembered who we are,